Let us first see what is a system. A system is defined as a quantity of matter or a region in space chosen for study. The mass or region outside the system is called surroundings, and the real or imaginary surface that separates the system from its surroundings is called boundary. The boundary of a system can be fixed or movable. Note that the boundary is the contact surface shared by both the system and the surroundings. Mathematically speaking, the boundary has zero thickness, and thus it can neither contain any mass nor occupy any volume in space. And what are the important classifications of systems? Systems may be classified as closed, open, or isolated, depending on the energy and mass exchanges with surroundings. A closed system, which is also known as the control mass, consists of a fixed amount of mass and no mass can cross its boundary. That is, no mass can enter or leave a closed system. But energy in the form of heat or work can cross the boundary. And the volume of a closed system does not have to be fixed. You can see in this example there is a moving boundary and also there is a fixed boundary. When the gas expands, the boundary changes. An open system or a control volume, as it is often called, is a properly selected region in space. It usually encloses a device that involves mass flow such as compressor, turbine or nozzle. Flow through these devices is best studied by selecting the region within the device as the control volume. Both mass and energy can cross the boundary of a control volume. A large number of engineering problems involve mass flow in and out of a system and therefore are modeled as control volumes. A water heater, a car radiator, a turbine, and a compressor all involve mass flow and should be analyzed as control volumes or open systems instead of as a controlled masses or a closed system. In general, any arbitrary region in space can be selected as a control volume. There are no concrete rules for the selection of control volumes, but the proper choice certainly makes the analysis much easier. If you were to analyze the flow of air through a nozzle, for example, a good choice for the control volume would be the region within the nozzle as shown in the figure. Another example of open system is the water heater. Let us say that we would like to determine how much heat we must transfer to the water in the tank in order to supply a steady stream of hot water. Since hot water will leave the tank and be replaced by cold water, it is not convenient to choose a fixed mass as our system for the analysis. Instead, we can concentrate our attention on the volume formed by the interior surfaces of the tank and consider the hot and cold water streams as mass leaving and entering the control volume. The interior surfaces of the tank form the control surface for this case, and mass is crossing the control surface at two locations. An isolated system is a system in which there is no exchange of mass and energy.